Hi guys, ako nga pala si Remin Magboa from IT2102 and today uh, I will discuss the quick summary about the chapter 6 in CNA1 entitled Network Layer. And now, let's get started. Network Layer. Network Layer Protocols. The network layer. It is the network which resides at OSI layer 3 provides services that allows end devices to exchange data across a network. It is the network used for processes. The first one is addressing of the end devices, encapsulation, routing, and then encapsulation. Network layer protocols that are several network layers in existence. However, the most commonly implemented are the Internet Protocol version 4 and the Internet Protocol version 6 that are in short in is the IPv4 and the IPv6. Legacy network layer protocols are not discussed in this course. Encapsulating IP. This is the IP encapsulates the transport layer segment by adding an IP header for the purpose of delivery to the destination host. It is the routers implementing different network layer protocols concurrently over a network and use the network layer packet header for routing. The process of encapsulating data layer by layer enables the services at different layers to scale without affecting other layers. And the IP header stays the same from the source to the destination host. Characteristics of IP. It is designed as a protocol with low overhead. It is provide only the function required to deliver a packet from the source to the destination, and then the IP packet is sent to the destination without prior establishment of a connection. And IP was not designed to track and manage the flow of packets. The IP connectionless that protocol, no, it's very similar process as sending someone a letter through a snail mail, and then the senders do not know whether or not the destination is present, reachable, or functional before sending packets. Its no dedicated end-to-end connection is created before the data is sent. This is the IP best effort delivery. It is the packets are routed through the network quickly, and some packets may be lost en route. As an reliable network layer protocol, IP does not guarantee that all sent packets will be received, and the other protocols manage the process of tracking packets and ensuring their delivery. And then, IP is considered unreliable because it's not guaranteed to all packets will be received. And packets are missing or not in the correct order or destination, it is must resolve these issues. IP media independent. The IP operates independently from the media that carries the data at lower layer of the protocol stack. It does not care if the media is copper cables, fiber optics, or wireless. The OSI data link layer is responsible for taking the IP packets and preparing it for transmission over the communication medium. It is the data link layer tells the network layer, the MTU. This is the IPv4 packet header. It is have significant fields including the version, the DS or the differentiated services, time to live or time to live or the TTL protocol, source IPv4 address, and the destination address. Limitation of IPv4. This is the introducing the IPv6. It is the advantage of IPv6 over IPv4, including the no need share address with IPv6. The encapsulating IPv6 header is simpler than the IPv4 header. Encapsulating IPv6 is the elimination of need for network address translation, or the NAT, between private and public addresses. IPv4 packet header is a version, traffic class, flow level, payload length, next header. And it's contain of 6 headers fields. And also in the hop limit, source IPv6 address, destination IPv6 address. In routing, the host forwarding decision is an important role of the network layer is to direct packets between hosts. A host can send a packet to itself, local host, remote host, and the source IPv4 address and subnet mask is compared with the destination address and subnet mask in order to determine if the host is on the local network or remote network. The default gateway. It is the network devices that can route traffic out to the other network. It is the other router that routers traffic out of a local network. This is occur when the destination host is not on the same local network as the sending host. Using the default gateway, the host receives the IPv4 address for the default gateway from DHCP, or it is manually configured. This is the host routing table. On the window host, you can display the routing table using the route print and then netstat-r, and have a section that displayed the interface list, IPv4 route table, and IPv6 route table. Router packets forwarding decision. And the router receives a packet destined for a remote network. The router has to look at its own routing table to determine where the forwarding packets. A router routing table contains the directly connected routers, remote routers, default routers. IPv4 router routing table is the show IP route command is used to display the router's IPv4 routing table. It is directly connected in remote routes, how each route was learned, when the route was last updated, and the router examines an incoming packet's header to determine the destination network. And if there is a match, the packet is forwarded using the specified information in the routing table. Directly connected routing tables entries, and the C or L. The C identifies the network connected and the interface is configured, and the L is identify the local interface. Understanding the remote routes entries. The first one is the 10.1.1.0 that over 24 that identifies the destination network. 90 is the administrative distance for the network. And then there's 2170112. It is represent the metric or the value assigned to reach the remote network. And the 209.165.200.26 is the next hop or the IP address for the next router to forward the packets. And the 000005 is a timestamp identifies when the router was last heard from, and the serial 10 or the serial 0 over 0 over 0 is outgoing interface. The next hop address is when the packets arrived at a router destination for a remote network. It will send the packet to the next hop address corresponding to the destination network address in its routing table. This is the routers in a computer. It is a router is a computer that like computers, a router is requires a CPU or the operating system and the memory. It is having a branch one service provider, and the focus of the CPU and OS of the router is like computers. Cisco routers require a CPU to execute OS instructions, including system initializations, routing functions, and switching functions. The router memory have a volatile memory that requires continual power to store information, and the non-volatile memory does not require continual power. And it is have four types of memory. The first one is the RAM, it's the ROM, and the NVRAM, and the flash. There are the numerous types and models of routers. However, they have the same general hardware components. The first one is the power supply. Second one is the cooling fan. The third one is the SD-RAM or the synchronous dynamic RAM. Non-volatile RAM or the NVRAM, and CPU heat shields advanced integration module or the AIM. Connect to a router, which includes the high-speed WAN interface card, auxiliary or the AUX, console port, or the Gigabit Internet used to provide LAN access by connecting to switches, users, or the other routers, USB port, compact flash slots. LAN and WAN interface. The first one is the in-band routers interface, the LAN and WAN interface, management ports, this is the console and the AUX ports. Cisco routers and switches load the iOS image and startup configuration file into RAM when they are booted. This running configuration is modified when the network administrator makes any changes. Router boot up process. There have three major phases. The first one is the performing the post and load the bootstrap program, locate and load the Cisco iOS software, and locate and load the startup configuration file or enter setup mode. It is the show version output that commands display information about the version of the Cisco iOS software running on the router, as well as the version of the bootstrap program, amount of system memory, information about the hardware configuration. Basic switch configuration steps. The first one is the Cisco routers and switches have many similarities in regards to their configuration. Support a similar operating system, support a command structure, support many of the same commands, and commands on the left display a sample configuration of a switch. It is also have identical initial configuration steps when implemented in a network. This is the basic router configuration step. The first one is the configure the router's device name, secure the user exec mode, secure remote telnet and SSH access, secure privilege exec mode, secure all password in the config file, provides legal notification, authorized access only, save the configuration. Configuration interface have a 2 GB interface that reachable by other devices in the network, or the devices in the in-band interface must be configured. Verify interface configuration have 4 or 3: show IP interface brief, show IP route, show interface. And remember how to save this copy running config startup config command. Default gateway for a host: when the default gateway is only used when the host wants to send a packet to a device on another network. If the device is on the same network, it can send it directly to the devices. Default gateway for a switch is in the an IPv address subnet mask and default gateway address are required in order to connect to it remotely. Done.